All right, guys, so you need the note sheet out from yesterday. Need the note sheet from yesterday, guys. So you need your note sheet out from yesterday. I believe we finished off on this problem here. Or did we finish off on the one before it? One before it. So guys, this is where we're going to start today. We're going to go through this note sheet, and then we're going to do 6.3 or 6.63. So we're finishing 6.62 and then going through and completing 6.63. 6.63 only has two problems that we're going to look at. So this here is where we stopped. We stopped with the problem before this one here. So we'll be looking at this one here to start with. Solving log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. So the note sheet from yesterday. And then we'll be doing this other note sheet today. Now, whenever we solve logarithms like this here, we need to rewrite these two logs as a single log. And we can do that because whenever we have two logs with the same base being added together, we can rewrite it as a single log with what's being inside of each log is being multiplied together. So we would have 6x times x minus 1. So we can rewrite log base 6 of 6x plus log base 6 of x minus 1 is equal to 2, as log base 6 of 6x times x minus 1 is equal to 2. So we can rewrite the two logs as a single log. Now from here we do need to simplify the logarithm, and to do that we're going to put both of these to the base of 6, because 6 to the log base 6 cancels out, leaving us with just 6x times x minus 1 is equal to 6 squared is 36. So the key part for this here is putting the two logarithms together and then using a base of 6 to simplify it. Now we just need to solve 6x times x minus 1 is equal to 36. So the first thing we can do is distribute the 6x. 6x times x is going to give us 6x squared. 6x times negative 1 is going to give us negative 6x is equal to 36. Since we do have an x squared term, we do need to get everything on one side of the equation, and this equal to 0. So the next thing we can do is to subtract 36 from both sides. And when we subtract 36 from both sides, we get 6x squared minus 6x minus 36 is equal to 0. Now at this point here, we do need to solve for the value of x. Now there's different ways we can do it. We can go about graphing it, factoring, or using the quadratic formula. Now if we factor it, we can grab the calculator and go y equals 6x squared minus 6x minus 36. We can type it into y equals and hit graph. And if we do this here, we're looking to see where it crosses the y-axis. We're trying to see what values of x will make this function equal 0. And we do have two places that it crosses. So if we go second table, one of the values of x that makes the y value equal 0 is negative 2. The other one is at 3. So what that tells us for this here is that x is equal to negative 2 and x is equal to 3. But again, whatever's inside the logarithm cannot be negative or 0. And if we look at negative 2, well, log base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1, we will get two negatives. Because here we'll have negative 12, and here we'll have negative 3. We cannot have a negative inside the log, so x equals negative 2 does not work. It does not work in our original equation. Now, if we did the same thing with 3, 6 times 3 plus log of 3 minus 1, well, 6 times 3 is 18. 3 minus 1 is 2, and this will work out to be 2. So the correct answer for this here is x is equal to 3. X is equal to negative 2 does not work. Any other questions on any of this here? We can mark through this one. I want to do ln of x plus ln of x plus 3 is equal to 4. So I want to add this one in. So the one that was supposed to be this here, log of 5x plus log of x minus 1, you can mark that out and put this one in. And we're going to work through this one here, because this one here is a little bit weird in some of the processes that we have to do. Now again, whenever we have two logs being added together, we can rewrite this as a single logarithm of what's being inside is being multiplied together. Because again, we need it as one log for us to be able to simplify and solve. So we rewrite the natural log of x. Okay, so let's focus up here. And the natural log of x plus 3 as the natural log of x times x plus 3. And the reason we do this is to simplify the log by putting both of these to the base e. Because e to the ln cancels out, leaving us with just x times x plus 3 is equal to e to the 4th. Because we're going to leave it as e to the 4th, because unfortunately e to the 4th is an irrational number. It does not have a nice number with it, so we will leave it as e to the 4th. Now the next thing we can do is distribute the x. X times x would give us x squared, plus x times 3 is 3x is equal to e to the 4th. Now again, since we have an x squared term just like the one before, we need to move it over and get this equal to 0. So what that'll tell us is that we have x squared plus 3x minus e to the 4th is equal to 0. Well, do we know how to factor this here? Well, no. E to the 4th is a number, but it's not a rational number. So most likely our solutions are not going to be factorable or graphable. So we'll have to use the quadratic formula. Now if we plug these values in, our b value in this case, because here we have a, b, and c, so the value of b is 3. Plus or minus, so b squared would be 3 squared minus 4 times a is 1 and c is negative e to the 4th. Because negative e to the 4th is just a number. E to the 4th is just a number. It's irrational, but it's still a number. over 2 times 1, which would be over 2. Will the number that comes out of this square root be a nice number? Well, no, because e is not a nice number to begin with, and if we're square rooting it, it's not going to be too nice from there. But we can use the graphing calculator. We can use a calculator to calculate this out. Because what we can do is pull up the fraction and say -3 plus second square root 3 squared minus 4 times 1 times negative e to the 4th all over 2. So we can type that quadratic equation into the calculator. It'll solve it for us. We don't have to do this step by step. And if it comes out to give us an error, it doesn't work anyways. That solution does not work. But we do have to consider the other case because it is plus or minus. So we can come back here and change it from plus to minus and get this here. So 6.04 or negative 9.04 would be our 2 answers. Would be these 2 answers here. Now, if we look back at the original equation, the 2 places we have x are here and here. In either one of those places, do we have anything that's going to affect that negative? That number from being negative? Well, no. So it's -9. -9. Well, in the first one, it's still going to be -9, yes? And the other one, -9 plus 3 is -6. Both of those are still negative. Those do not work. So this here is not the correct answer. The only one that is the correct answer for this here is 6.04. Yep. I think they're trying to fix it. Any other questions on this here? Any questions on anything we've done so far? Glasses off. Thank you. There's no other questions on this here. We'll move on to the last part of 662, which is talking about inequalities. Now, the way that we solve inequalities is the same as we were solving with exponential equations. The only main difference is if we multiply or divide by a negative. If we multiply or divide by a negative, we've got to change the sign from less than to greater than, or greater than or equal to less than or equal to. Now, when we were looking at these yesterday, the way that I would get the variable out of the exponent is to apply a log base 3 to both sides. We would apply log base 3 to both sides. Because on the left-hand side, log base 3 of 3 to the x, we can move the x out front, which would give us x times log base 3 of 3 is less than log base 3 of 20. And here, log base 3 of 3 simplifies to 1, telling us that x is less than log base 3 of 20. And at this point here, we just need to calculate what log base 3 of 20 is. And we can use the graphing calculator and go math. Log base 3 of 20. And see that it's 2.7268 or 2.727. And that would be it. Because when we're looking at the original problem that's dealing with exponents, the variables in an exponent, the numbers can be positive, negative, or 0. There's no restrictions on it. So for this here, this is it. This is all we have to do for this here. Any questions on this here? Let's look at the next one. E to the x is less than 2. For this one here, we would apply the natural log to both sides. ln. Because ln of e to the x would move out front, telling us that we have x ln of e is less than the natural log of 2. ln of e is less than the natural log of 2. Now ln of e reduces to 1, telling us x is less than the natural log of 2. And at this point here, we just need to calculate what the natural log of 2 is. And we can plug that in a calculator and see that is 0.693. Any questions on any of this here? We'll go on and look at the last type dealing with logarithms here. Now, whenever we talk about an inequality with logarithms, what's inside the log cannot be 0 or negative. So in this case here, x has to be greater than 0. What's inside the log has to be greater than 0. Now, if there was more than just x, if it had been 2x plus 7, we would have to solve to see what would make what's inside the logarithm be 0. Here, it's just x has to be greater than 0. And we need this to be true, or not, is a true statement. And we need it so that whenever we solve the logarithm, if any values that would make this false are applied or contained in our solution set, we need to exclude them. So, now we can look at the actual problem. Log of x is less than or equal to 2. So to solve this, we're going to use the base 10. Because 10 to the log of x, 10 in that log would simplify out, giving us x is less than or equal to 10 squared. And 10 squared is 100. So that's all we had to do was apply that base 10 to both sides, and it simplified everything out. We've got x by itself, yes? Now, x has to be greater than 0, yes? Is 0 less than 100? Yes, but we said it can't be included, so we have to add the restriction that x has to be greater than 0. So 0 is less than x is less than 100. So if the numbers in this restriction come into play or are true for the overall solution, we have to add that in. If they're not true, then we don't need it. Because if this had said x is greater than or equal to 100, well, it doesn't matter if x is greater than 0. Because 100 is greater than 0, those don't come into play, so we wouldn't need it. Any questions on this here? Yes. Is negative 1 less than 0? Right, so can x be negative 1 in this solution statement here? So we've excluded it. Yes. Any other questions? All right. We're going to look at one more of these here. So for this one here, we need to go on and put the parentheses around x plus 9. Now, if there's not parentheses already included, it's not necessarily considering it to be x plus 9. Because the way this problem is actually supposed to be looked at is like this here. Because if there's not parentheses around both the x plus 9, it's just talking about x being in the log. The 9 is not included. But for us here in this problem, I want us to work it as if x plus 9 was contained inside the log. Now, the reason we're doing this is because, again, what's inside the logarithm cannot be 0. So x plus 9 has to be greater than 0. It cannot be equal to 0 or negative. So any values of x that would make what's inside the log 0 or negative cannot be included in our solution. Now at this point here, we're going to go on and solve it. So we'll subtract 9 from both sides, telling us x has to be greater than negative 9. Because for how we have this problem set up, if x is negative 9, well, negative 9 plus 9 is 0. That would give us 0 inside the logarithm. Any questions on this here so far? Now we can go on and start solving this here. So we have log of x plus 9 is less than 45. Now to simplify the logarithm out, we're going to put both sides to the base 10. Because 10 to the log of x plus 9, 10 in our log will cancel out, telling us that x plus 9 is less than 10 to the 45. Now what do we need to do next to solve for the value of x? We need to subtract 9 from both sides. And if we subtract 9 from both sides, we get that x is less than 10 to the 45th minus 9. I'm going to leave it as that there because 10 to the 45th is a massively large number, and we're going to leave it there. Is negative 9 less than 10 to the 45th minus 9? Oh yes, any number. Most numbers are less than that. So we have to include the fact that this here has to be greater than negative 9. Really, any time where we have a value of x less than a number dealing with logarithms, we're going to have to add that restriction in. And that's it there. Any questions on any of these here? Any questions on anything we've done so far? All right. That is it for those there. So 6.62, we're finished up with that there. So go on and write this down, and then we're going to go on and start on 6.63. All right. So we're going to look at two problems in 6.63, and then we are done for today. Now for 6.63, what we're adding here is not too much different than what we did at the start of this lesson. 6.63, the subtraction, we still need to rewrite this as 1 log. But unlike yesterday, well, we did 1 yesterday and 1 today, whenever we subtract 2 logs, we're not going to rewrite it as multiplication. We're going to rewrite it as division. But everything else about this problem is going to be the same. Because once we rewrite it as 1 log, we can go through the same processes. So the next thing we need to do is simplify the log. Since it's understood the base is 10, we're going to put both sides to the base of 10. Because 10 to the log cancels out, leaving us with 3x minus 2 divided by 2 is equal to 10 cubed. Ten squared is 100, so multiply by 10 one more time, and we get 1,000. Now we just need to solve for the value of x. So the next thing we can do is multiply both sides by what? 2, because the 2 and 2 would cancel, telling us 3x minus 2 is equal to, well, 1,000 times 2 is 2,000. And what can we do next? We can add 2 to both sides, which will tell us that 3x is equal to 2002. And last but not least, will this divide by 3 evenly? Any number whose sum of its digits is divisible by 3 will also be divisible by 3. Well, 2 plus 2 is 4. Does 4 divide by 3 evenly? No, so neither will this. We should get 667.33333, or 667 and a third. Either one of these here is the correct answer. Any questions on any of this here? Are we ready for the last problem of the day? Okay. So this one here is the last problem we're going to look at today. Log base 4 of x minus log base 4 of x minus 1 is equal to 1/2. So when we divide or subtract 2 logs with the same base, we can rewrite it as a single log where what's inside the logarithm is being divided. What can we do next? Set it to a base of 4, yes. Because the only way to undo the logs, go on and kick them. Yeah. Welcome. So when we do this, 4 to the log base 4, these cancel out, giving us x over x minus 1. Now we need to figure out what 4 to the 1/2 is, because this 1/2 is the same as the square root. Square root of 4 is 2. What can we do next? We wouldn't multiply everything by -1. It would be x minus 1. Because on the left-hand side, we would have x minus 1 over x minus 1. Anything divided by itself is 1. So these would cancel out, leaving us with x is equal to 2 times x is minus but we still need to get x by itself. I would go on and subtract 2x, because x minus 2x is negative x, which is equal to, well, if x is negative x is equal to -2, positive x would equal and that's it. Questions on any of this here? And that's all we're doing today. So that is last part, and this is 6.63.